Okay, guys. So today, we're going to be doing something a little different. I'm not going to be lecturing today. Um, Today, we're going to actually do a virtual lab. So we have a virtual lab planned. I'm gonna kind of get you guys started on it and kind of walk you guys through the basic steps. It's an inquiry-based lab, so really this is something you guys supposed to be figuring out on your own. But I'm gonna get you started. I'm gonna walk you guys through it. Um, some people are asking me for the attendance form in the chat box. Guys, give me just a second. Okay, so let me go ahead and share my screen so I can show you guys what you guys are gonna be doing today. The assignment's already in Schoology. Let me just go ahead and pull it up. Okay, so as you guys know, we are in the second unit, which deals with forces, Newton's laws of motion, and things like that. So, this lab today, this virtual lab, ties very heavily into the second unit. Now, normally, this lab activity or lab activity similar to it, I normally like to do it midway through the unit. However, like NIMSY is going to be wanting us to do this lab with you guys, and they want me to have the data and some student samples to them by tomorrow, because I actually have classes too, and I have my NIMSY class every Thursday at 7 p.m. So I have to have the data submitted to them by tomorrow. That's why we're going to go ahead and start the lab today. So we're going to do this lab to kind of start the unit and to kind of introduce forces and Newton's laws and things like that. Okay, so let me click on the folder for today. Okay, we're in the second 6 weeks. The day is Wednesday. Okay. Now, so guys, what do you see here? This is the instructions for the inquiry lab, which deals with force, mass, and acceleration. And then, guys, as soon as you're done with your graphs and writing out your procedures and your conclusion, you're going to take a picture of everything and submit it to this assignment box here that says Inquiry Virtual Lab Submission. Okay, so that's the goal for today. Like I said, I'm not going to be doing any lecture on today. I'm just going to get you guys started on the lab, and basically you have all class period to get this virtual lab done. And of course, I'm going to be on to answer your questions if you need me to. Okay, so if you click on it, let's go ahead and read the instructions for what you guys are going to be doing today. Okay. So it says, in this lab, you determine what is the relationship between force, mass, and acceleration. For those who are working virtually, you will use the following website list below and click on the icon that says acceleration. Okay, so guys, this is the website you're going to go to. You're going to go to this website right here. It's a PhET simulation. Okay, and then you're going to click on the icon right here that says acceleration. Okay, and you're going to use this to collect your data points to do your lab. Okay, so basically, guys, as you figure out the relationship between force, mass, and acceleration, you're going to have two graphs. Okay, by the time you're done with this, you're going to have two graphs, and of course, I've given you guys graph paper here in case you guys want to print it out and put your graphs, put your data on the graphs here, or if you guys want to make your own graphs, that's fine as well. Just be sure to use a straight edge or some sort of ruler. So where am I? Okay, so it says it is up to you to design the experiment while correctly deciding which variables to hold constant and which variables to change, depending on the particular relationship you are testing. Use the graph paper provided to plot out your data and draw some conclusions from the data. Okay, so hint, you want to have two graphs. One graph that shows the relationship between acceleration and force, and another graph that shows the relationship between acceleration and mass. I'm going to say that again, guys. You're going to have two graphs. One graph shows acceleration on one axis and force on the other axis. and the other graph shows acceleration on one axis and mass on the other axis. Okay, and it's up to you to figure out what goes on your y-axis and what goes on your x-axis. Remember from your previous science classes, your y-axis is your dependent variable, and your x-axis is your independent variable. Okay, so let me just show you guys briefly how you're going to collect your data. Suppose I'm figuring out the relationship between acceleration and force. Okay, so if I'm figuring out the acceleration between acceleration and force, I want to hold my mass constant. Okay, so I'm going to come over here. Okay, and notice, guys, this guy here, you can have the guy to push the box and cause the box to accelerate. Okay, so, and you can vary the force, you can vary the mass however you want to. Okay, let me reset this. So, guys, as you're doing your lab, come over here and check these values right here so that you'll know the magnitude of your acceleration whenever you are applying your force to your object. And guys, here's another thing that you guys want to do. To make sure your data is accurate, take friction here and turn friction off. So you don't want any friction on your surface because you don't want friction interfering with the value of your acceleration. So if you turn friction off, notice it makes the surface like ice. So you know it's completely frictionless, or in other words, friction is negligible. You can ignore it. So, for example, let us suppose we're finding the relationship between force and acceleration. What you want to do in that situation right here, you want to hold the mass of the object constant. So here I have a mass that's 50 kilograms. Okay, and let's say I apply force. I don't know. Let's say I apply a force of 100 newtons on a 50 kilogram object. So in that case, if my force is 100 newtons, then what is my acceleration? Can y'all look at the top right here? What do y'all notice for my acceleration? Anyone?
2 meters per second squared.
It was 2 meters per second squared. So what you guys want to do, you want to take that and you want to write that down, that whenever my force is so many newtons, my acceleration in that case was 2 meters per second squared. And so guys, you want to take several data points, at least 5 or more data points, write that out and then plot that on a graph so that you can figure out what is the trend there. What is the relationship between force and acceleration? Okay. And then you're going to do the same thing with the relationship between mass and acceleration. And obviously, guys, you can actually change the mass of your object by adding more crates to it. So, for example, like here, my total mass is 100 kilograms because I have a 50 kilogram object and a 50 kilogram object, and I add them together, that's 100 kilograms. And again, you can add how many masses you want to your object. Okay, and of course, notice how, oh, I'm sorry, let me turn friction off. Okay. Notice how as I apply force on my object, notice how the acceleration changes. Okay, so, and obviously if I release that force, the object just moves at a constant velocity or constant speed because that's Newton's first law. An object in motion will stay in motion if there are no forces acting on it. But as long as there's a force being applied, there's clearly an acceleration. Now, we're not concerned with constant speeds here. The main thing we're just concerned with is the rate of acceleration of our object. Okay, let me reset this and start over from the beginning. Okay, so guys, let me write out just a few things that I want you guys to do. Again, you cannot use the examples that I'm doing. You have to do your own data. So, for example, so the first example that I want to do, I want to collect data where I want to figure out what is the relationship between force and acceleration. Okay. So if I want to figure that out, I just come over here. Okay. And guys, I want to cut out my values here because I want to be able to read everything. And guys, it's up to you whatever mass you want to use starting off. It's completely up to you. You can use a 200 kilogram mass if you want. So here, this is a 2 kilogram mass. So guys, notice what happens if I apply a 100 Newton force to a 200 kilogram object. So guys, what do you guys notice? What is my acceleration here? Can y'all see that? Anyone want to tell me?
0.50
Yeah.
meters per second squared.
Yeah, so 0.5 meters per second squared. So I want to write that down as my first data point, that whenever my force is 100 newtons, my acceleration is 0.5 meters per second squared. And guys, it is your responsibility to collect more and more data points so you can plot it out. I'm going to reset this here. So what if I want to get another data point? Remember what I said, guys. Whenever you're figuring out the relationship between force and acceleration, you want to hold mass constant. So now I want to get another data point. So instead of dealing with 100 newtons, let's say I apply 200 newton force. No, rather yet, let's say I apply 150 newton force. So let's say my force is 150 newtons. So if I apply 150 newton force on my object, okay, what is my rate of acceleration? Can someone tell me?
0.75.
Yeah, so 0.75 meters per second squared. So then once you have that, guys, you would then take that value. Let me go over here. You would take that value and you would write it down. So 150 newtons, 0.75. And guys, I'm gonna collect one more data point just so you guys get the basic idea of what you're doing. And again, the data points you use cannot come from my examples. So I'm gonna choose another data point. Again, turn friction off. So remember, I'm holding mass constant. So let us see what happens if I apply 250 Newton force. So if I apply 250 Newton force, I'm sorry, 200 Newton force, excuse me. A 200 Newton force. So guys, if I apply 200 Newton force, what is my acceleration here? Anyone?
1 meter per second.
1 meter per second squared. Yeah, so the acceleration here, so for 200 Newton force, it would be 1 meter per second squared. Okay. And guys, you would do that in order to see the trend. I need a minimum of 5 data points. It can be 5 or more data points, but it cannot be less than 5. And again, guys, this was a situation right here where we were holding mass constant at 200 kilograms. Be sure you tell me that in your procedures, all right, what you're holding your mass constant at. Now, for your second graph, guys, you want to figure out the relationship between mass and acceleration. Okay. So someone tell me, for this graph, if we're figuring out the relationship between mass and acceleration, what are we holding constant here? What do y'all think? Anyone?
Can you repeat that?
So here we were figuring out the relationship between force and acceleration. But what if I was wanted to figure out the relationship between mass and acceleration? What do I have to hold constant here? The force, exactly. The force. So guys, so here's how I want to do this. So again, let me turn friction off. And for this situation right here, okay, tell her I say hello. All right. What class you got this period? What class you got this period? Yeah. Elijah, put on your mask. Put on your mask. Keep the mask on. All right, take it easy. Remember, keep your mask over your nose too. That's good practice. All right, take it easy, man. All right, guys. So here we're gonna hold force constant. Okay. So for example, let's suppose I have a 50 kilogram mass, and I don't know, let's say I apply um, I apply 50 Newton force on the object. So in this case right here, if I apply 50 Newton of force, notice my acceleration is 1 meter per second squared. Okay. So when the mass is 50 kilograms, the acceleration is 1 meter per second squared. Okay. Now, guys, remember what I said. We're holding mass constant. So since we're holding mass constant, I'm sorry, we're holding force constant. Since we're holding force constant, we're going to change our mass. So remember, I click that button to reset. So now instead of 50 kilograms, what if I want to change my mass to 100 kilograms? Right, because 50 plus 50 is 100 kilograms. Okay. Remember, I'm holding my force constant, so my force has to be at 50 newtons, and there can't be any friction. Let me turn friction off. So 50 newtons of force. Okay. If you guys notice, my acceleration here is 0.5 meters per second squared. So whenever this is 100 kilograms, so 0.5 meters per second squared. Okay. And guys, so let's keep going. What if I was to have my mass at 150 kilograms? So if I was to have my mass at 150 kilograms, basically what I need to do is so I'm gonna add a bucket of water there. So 100 plus 50 gives me 150 kilograms. So now let me push with a 50 Newton force. Remember, the force has to stay constant. So guys, if my force stays constant at 50 newtons, can someone tell me what's my acceleration there? Can y'all see that?
0.
Yep, 0.33. So whenever the mass is 150 kilograms, my force is 0.33 meters per second squared. So that gives you guys an idea of what you guys have to do. Again, you cannot use these values here. Everyone has to have their own values. This is your experiment. It's an inquiry-based lab. As you are doing this lab, it is up to you to determine what happens as you change force and as you change mass. So guys, let me go back to this. Okay, so guys, once you collect your data, and again, you want at least 5 data points, 5 or more, just so you can see the trend. It's up to you to use the graph paper provided. So I gave you guys 2 graph papers here and here, in case you want to, in case you guys want to print that out and use my graph paper, or you can create your own graph paper. It's totally up to you. And guys, it is up to you to figure out what goes on your y-axis and what goes on your x-axis. Okay. As soon as you guys are done with that, with your graphs, then you're ready to write up your procedures and then your conclusion. Guys, on your procedures, please don't give me any unnecessary steps. Like, don't tell me, well, open up your internet browser, go to this website, click on this. Don't say all of that. Don't give me any unnecessary steps. Just pretty much tell me what you're doing. You're saying, well, whenever we're figuring out the relationship between force and acceleration, we will need to hold mass constant. So if we're holding mass constant, and then we push with so many newtons of force on our object, and we got this acceleration, and then you will tell me. Then from there you will repeat that. You will apply force several times to figure out what the acceleration is, and then once you have your data, you're going to graph it out. So that's basically what your procedures have to include. Your procedures have to include basically just the steps you're taking to get that data, and then plotting out the data on a graph. And of course, the conclusion is how are you going to interpret the data. Okay. So once you're done with your graphs, you're ready to give me your conclusions. And your conclusion just basically includes your overall trend. Your trend is, well, you will tell me, well, as I increase the force, this is what happens to the acceleration. Or if I increase the mass, this is what happens to the acceleration. You're just basically telling me what your trend is from your data after you have collected it. Okay, so everybody got that? So for today, what I need from you guys, I need these two graphs, and I need your procedures, and I need your conclusion. Okay. Any questions? Okay, guys, there are two ways you can access that website. That website is on the instructions that I gave you. But if you guys click on where it says Inquiry Virtual Lab Submission, um, the link is right there as well. When you can click on it. Any questions for me? Guys, if you decide to draw your graphs, please draw your graphs neatly. Use some sort of ruler or some sort of straight edge to make sure it's pretty neat and even, because you want to see that basic trend. The trend. In order for you to see the basic trend in the data, the graph has to be done neatly. Okay. Any questions? All right, guys, y'all can go ahead and get started. I'm gonna keep the Zoom call open till 3:20 in case you guys have any questions while you're working on your virtual lab. But guys, this is an inquiry-based lab. In other words, this is something that you have to do largely by yourself. It's up to you to collect the data. You plot out the data and then figure out the meaning of the data. This is something that you have to do on your own. Okay, the submission box is already in Schoology, so as soon as you guys get done, you can upload your pictures at any time. All right, if you guys have any questions while we're working on this, just let me know. Devin, you want to print out some graph paper? Okay. Huh? Yes, sir. Okay. Now, technically, like the rule is, I can't touch anything and give it to you. But once I print it out, you just come over and get it, because Mr. Joseph doesn't want us, exchanging stuff paper wise. So, but when it comes out, you can just come get it.